welcome to the Might Ramble podcast.
Ron, tell us about that.
Not 2, not 3, not 4, not 5.
Now I am become death, the destroyer of worlds.
From this distant vantage point, the Earth might not seem of any particular interest.
Part of my aim with my writing and my speaking is to take information that is usually not understandable to non-research scientists and make it understandable to people that have a scientific curiosity. There is amazing, amazing research out there. It's usually just not communicated very well. So this is going to be a data presentation trial. We have a paper. This paper is called Thermal Tolerance and Extended Lifespan Conferred by Single Gene Mutations and Induced by Thermal Stress. It's, a paper from 1995. It's 30 years old. It's a Saturday night, and here I am, reading this paper and playing around with the data because, I don't know, my curiosity got the best of me. Nonetheless, that title is a mouthful, so I thought we'd take a brief intermission. And if I were to put this in plain language, essentially what it means is that certain DNA mutations and even just a short burst of heat stress can make worms live longer and survive heat better. Okay, cool. What we're really focused on, and I touched on this in my boundary of knowledge piece, is that even just a short burst of heat stress can make worms live longer and survive heat better. So if you were to read this paper, you would encounter this graph. This isn't a very pretty graph, and it's not the most easily understandable. The axes aren't labeled. There is a long and belabored caption for this chart that you can sift through, but nonetheless, it's not entirely clear when you first look at this what the hell is even happening. So what if I tell a little story? We have C. elegans. C. elegans is a worm commonly used in aging research. It has about 1,000 cells. It has a lot of genetic overlap even with humans as far as processes that occur in the worm. Okay, cool. We have C. elegans. And what if I took one worm? We'll call this worm 1. And I took that worm and I grew it for 4 days at 20 degrees Celsius, which is the normal temp that you would grow these worms at. What would I have? I would still have my worm, right? And then what if I took that worm and I increased the temp and I heat shocked it at 30 degrees Celsius for 3 hours when it was 4 days old? So still pretty young. Okay, cool. Now we have a hot worm. And then what if I took that worm, now that it's hot and it's had a little exposure to the heat, and I put it under further heat stress at 35 degrees Celsius? What would be the question? How long does the worm live? Okay, so that's worm 1. Now what if I took a second worm and I did the same thing? I grew it for 4 days at 20 degrees Celsius. And then instead of heat shocking it, I just kept growing it at 20 degrees Celsius. And then I put it under heat stress at 35 degrees Celsius. What would be the question? Again, it would be how long does the worm live? In addition, one might pose, is there any difference in how long the worms live between worm 1 and worm 2? So, initially we had this ugly, horrible, terrible, no good, very bad chart. And what if I transform that into something that's a little more understandable? So on our y-axis here, we have the percent of worms still alive, going from 0 to 100. And on the x-axis, we have the time that it's spending at this high temperature, 35 degrees Celsius. In blue, we have the normal worms that never experienced a heat shock prior to being put at a higher temp. And then in the green, we have the worms that did have the heat shock before they encountered this high temp. What do we see? Well, first of all, let's get rid of that no good, very bad chart. And if I highlight this region here, the difference between the blue and the green, right? What do we see? We see that the green worms that experience some heat shock prior to being put at a high temp, they tend to live longer, right? And so that would be our takeaway. So this is just a trial. Thank you for checking this out. I very much am seeking feedback. Is this understandable? What could be better? What was good? For the research scientists out there or anyone who so would like to, if you just want to tear me apart and say, you should have X, Y, Z, and you should be a little more careful in what you're saying, please let me know. I really appreciate comments and feedback on this. That's all I got.